All right, there's a few more people trickling in, but we will go ahead and get started so we have enough time for Q&A after the presentation. Again, welcome to everyone joining, returning, as well as some new faces this month. Just some quick intros before we go ahead and get started with the press briefing. My name's Kristen Sisner. I'm Executive Director of Berkeley Earth. Joining on the call this morning is or will be Robert Rohde, our Chief Scientist at Berkeley Earth. And we also have Zeke Housefather and Devin Rand, both research scientists with Berkeley Earth, and as well as Kate Viscara, who helps keep everything running behind the scenes. Before I get started with intros, I wanted to go ahead and thank our contributing supporter for the Berkeley Earth Press Briefing Series this month. We want to thank Roxanne Guggen for her support of our work. We do this work thanks to charitable contributions and independent donations. So we greatly appreciate her support in keeping this series going. So go ahead and next slide, Robert. So quick intro to Berkeley Earth for those who may not be familiar with our work. We are an independent 501c3 nonprofit based in California. And our mission is dedicated to advance open and transparent climate science and making independent data products widely available and accessible. Our mission, our goal is essentially to empower data-driven climate action. As you already know, our expert team, Robert Rohde, Zeke Housefather, Devin Rand, and myself, Executive Director. Next slide. So the presentation and the report that you'll be seeing this morning is made using Berkeley Earth's high-resolution surface temperature data set. You can access this product with the QR code on the screen there. I think we'll also pop a link to the request form in the chat. This product is a 1/4 degree of resolution. We provide off-the-shelf subsets for more than 8,000 global cities. We also can provide Tmin and Tmax custom and national subsets as well. Again, feel free to request access to this product using the QR code on the screen. Just a quick housekeeping note, we will also go ahead and provide a link to the report after the presentation, and we will also make a recording of this call available later in the week, so that will be available to you as well. So that's the introduction. I'll go ahead and pass to Robert to kick off the presentation.
Okay, hello everyone. So this is our review of climate and weather in September of 2025. So in Berkeley Earth's analysis, we found that it was the 3rd warmest September since records began in 1850, just shy of 1.5 C above the 1850 to 1900 average, so 1.48 C. And this is behind the very warm Septembers that we had the last 2 years in 2023 and 2024. 2023 in particular being, rather bananas. If you weren't looking at the last 2 years, this current year would have stood out as a quite strong record. It's more than a 1/4 degree above any previous year up to 2023. But the last 2 years do stand out as very extreme, and we are continuing the long-term warming trend. Okay, so looking at it not just from the one September month, but looking at it as the month-to-month variation, we went a little bit of a dip earlier in the year, and now we've rebounded a bit in September and following August. We're still well off the highs of 2023 and 2024, but we are slipping a little bit higher. And you can also see that here, where we've graphed each year going from January to December, and all the years since 1850. The recent years and the last few years stand out as very warm in the latter half of the year, very warm in September. And we are expecting that the rest of the year will probably stay in this sort of window between what we had in the past and what we had in the last 2 years. So we'll probably close out the year it's somewhere close to this, but we'll have to see how it plays out. Looking at the spatial distribution for September, we had above average temperatures essentially almost everywhere compared to the middle of the 20th century, with warm conditions across Canada, Scandinavia, East Asia. Very warm conditions in the northern Pacific Ocean are continuing. That marine heat wave has been quite extreme. Warmth around much of Antarctica, and also southwestern Africa, but a little bit of cooling in the North Atlantic and a few other places. But 4% of the Earth's surface had a locally record warm September average, including about 3% of land and 5% of ocean. If you were looking closely at our map, you'll notice something a little unusual. We have some holes in this map in Africa, a couple other places as well. I want to comment briefly about this. There are some unusual gaps in our data due to the loss of NOAA services. So NOAA has for decades now been the leading aggregator of weather station data. They provide archives to researchers all over the world. Since late August, several of the NOAA aggregation services have been either partially or fully broken, leading to data not being updated. And while we have alternative data streams that don't rely on NOAA, and we're able to fill most of this map, there are places where we have missing data or reduced accuracy due to the less data. To elaborate on this just a little bit more, this is the flagship NOAA climate monitoring product called the Global Historical Climatology Network monthly data set. And the red dots on here are weather stations that are part of that data set that have not updated in the last 2 months, but were operational in July and earlier. And this speaks to a issue that NOAA has had internally with some of their aggregation services. We've been in contact with our counterparts at NOAA since they started appearing in September. And we're expecting that they will restore services eventually. But the team that's responsible for fixing their internal problems is currently at home because of the shutdown. So these issues won't get resolved until the federal government shutdown ends. And I would have to refer you to NOAA for any additional timeline on how long this is going to take. But like I said, we have alternative data streams. It's possible to get data from China and other places without relying on NOAA. It's just a bit of extra work and it leads to some extra uncertainty. Turning now to some more details about weather in September. This is now the land only average, the global land average. It was, again, the third warmest global average for global land, the third warmest average for global land in September, at about 2°C above the pre-industrial baseline. And it's also, I would note here that the uncertainty on the land average is the highest it's been in several decades, and that is, in part due to the disruption to NOAA data flows. And we will update our products when the data becomes available. So this is expected to be a temporary bump in uncertainty, but still well within the ability to understand what is going on with the climate. Looking again at the month's flows, we see land rebounding a bit in the warmth, going back towards this sort of neutral trend line, well off of the highs in 2023 and 2024, but not as far down as some of the lows that we saw earlier this year. For the oceans, we have a similar story. This is the third warmest September for ocean, uh, basically tying with the September about a decade back, but with a large uncertainty. So it's a little bit unresolved at the moment, but it's down off of the peak Septembers in 2023 and 2024. And again, we see this one is more in line with the long-term cooling trend. It's not quite as big. There was a bump in August, but we don't really see that at the moment, partly possibly due to the uncertainties around early ocean data, which gets filled in a bit more with a bit more delay. In turn to the climate conditions and what's driving climate right now. So we have seen additional cooling in the Central Pacific. We are officially in an ENSO neutral condition, according to NOAA and the organizations that regulate this, because we haven't cooled enough for long enough for them to call it La Nina. But we are very much on the cusp of doing so. If we stay where we are or just a slightly cooler, it will be considered a La Nina event, which would be a return to La Nina after we had one over the last winter. And again, this is a anomaly map for the Central Pacific, showing slightly cooling relative to what is a 20th century baseline, and in particular cooling beginning in the coastal area, which probably spreads westward and develops into a proper La Nina over the next month or two. Forecasts coming from the IRR Climate Prediction Center expects a 2/3 chance of La Nina developing almost immediately, September, October, November. And we will see how that plays out, with the likelihood that we see a return to neutral conditions next spring, if we develop La Nina as sort of expected at this point. Looking at where we are for the year, the average for the first 9 months puts us in the third warmest position, behind 2023 and 2024, but above all previous years before that. There is essentially no chance that we will be warm enough to set a record this year. There's a slight chance that we get to a second place warming if the next 3 months play out as very warm. But it's much more likely that we end up resolving the year as the third warmest overall. And there's only a slight chance that we get up to the 1.5C threshold, which like we did the previous 2 years. But a few months to go. And I would also mention that if La Nina develops, we'll probably stay on the cool side of this. We won't be pushing any records this year, and probably not next year, but we'll have to see how it plays out. So lastly, I want to give a brief preview of some coming attractions, and also make sort of a plea for how important is weather station data. So right now, the federal government is shut down, which means NOAA is not reporting climate data. NASA GISS is not reporting climate data. HADCREW, which is the UK center, they are operating, but they are coming off a multi-month hiatus due to institutional upgrades. So Berkeley Earth and what's known as ERA5, the reanalysis project, are the main groups that are really looking at climate condition on a month-to-month basis right now. ERA5 is a satellite and weather model-based reanalysis project. It's excellent, it's an excellent data set. I love it, but it has limitations. It does not use weather station temperature data in estimating surface temperatures. There's some technical reasons for that, but it also means that there's going to be some biases when you compare ERA5 and similar products to what stations actually show. And this chart here is showing an example of the differences between Berkeley Earth's work and what ERA5 estimates. And you find in the month of September, you have differences of the order of a couple degrees in across North America, which is an area where you have exceedingly high density of stations. So these are almost certainly going to be limitations of ERA5, that we have more than enough station data to get these anomalies pinned down with a high degree of precision. But ERA5 is, gets it a little bit off. Whether that difference matters to people is probably not a huge issue. But ERA5 also has issues with local and regional warming trends. So this is a map now of the trend difference over the last 50 years. Areas shown in blue are areas where ERA5 overestimates the local warming trends compared to what weather stations show. Areas in red are places where it underestimates it. And this is telling us that even though we have these excellent reanalysis products, which are very useful for many things, we really need weather station data as the gold standard for understanding temperature change on the ground. And we need organizations like NOAA playing a role aggregating that data. We need analysis groups like ours and like others preparing and understanding what's going on with that data. And anyway, this is a preview of a paper that will be forthcoming where we look more systematically at Berkeley Earth versus ERA5 to understand the advantages and limitations of reanalysis compared to anyway, thank you for listening. We will be happy to take some questions about this report or other issues. And you'll hand back to my colleagues.